Today's lecture is chapter 9, final revision, and why geology. So it's just a quick revision. Of course, you know all the chapters. We made full revision for all chapters. So it will just be a very quick linking between all chapters. Then a summary for why we are studying geotechnical engineering. This is I think this is the most important part in all of our syllabus. Why are we studying? We are engineers. Why we are studying geotechnical engineering? This lecture will be divided into 4 parts. The first part is the introduction. Of course, the introduction is what you have seen before, exactly what you have seen before. Why we are studying geology? This is a photo summarizing what we have said before. Why we are studying geology? To prevent something like this. Why we are studying geotechnical engineering? Of another photo summarizing. If you refer to this lecture, you will find that we spoke about the insufficiency of the geotechnical studies that were done for the stages of construction, how to construct this building so it collapsed. So this is why we are studying geotechnical engineering. What is the relation between geology and geotechnical engineering? Geology is a science, geotechnical is engineering. What is the relation between science and engineering? So we said that science is divided into many groups. We'll take the natural, then from the natural the physical, from the physical we'll take earth science. From earth science we have geology and hydrology as the 2 sciences that we are interested in. Those 2 are the basis of geotechnical engineering. So now we know the relation between geology and geotechnical engineering. What about engineering and science? Science, we said that the science studies all the problems around us, but scientists do not propose a solution for these problems. Engineers propose the solution. So this is the part of engineering. So in geotechnical engineering, we deal with the problems of the earth and we try to propose solution for this. How can we do this? By analyzing the problem, designing the problem, and then constructing the building or the structure that we need. So these 3 stages are related to our engineering phase of design, of study. What are the types of geologic data? This is also important because you will find problems in some geotechnical courses that are given to engineers that includes lots of data that are not important for us. So we need to know which data that we should use. There is data that is important to all people. Anyone on this earth should know this data. Of course, if we are speaking about earthquakes, volcanoes, tsunamis, this is something we all discuss. So for us, we should know this data. Data that is important to civil engineers. It is important only for civil engineers. Something like climate, weathering. These are a little bit specific data, but it is specific for civil engineers. So we should know it also. Data that is important to geotechnical engineers. Specifically for geotechnical engineers, faults for all the geological structure that we have studied. This is very important because it helps us to understand how, when we perform a site investigation, we can expect what to find. So it is related to a special type of civil engineers. These are the geotechnical engineers. So 1, 2, and 3 are very important for us. We should know them. But there is data that is important to geologists, only for geologists. These are specialized information about the history of the earth, minerals, how it was formed, lots of data that if we study them, we should take minor information. So this is what we are going, in our syllabus, we studied something about the history of the earth, but we took only minor information to know what are the data that are important for geologists. So this is very important. This ends our introduction. Part 2 is geologic study plan. How are we going to put our plan for the study to be well-informed geotechnical engineers, of course informed about geology? These are the 4 points that we should look at what you have studied before and put them into these 4 points. First point, geomorphic processes. These are the forces shaping the earth. You have studied geomorphic. We are going to review them now. Geomorphic process. These are the forces shaping the earth. Geological structure of the earth. This is the second thing, because after the earth was formed and was shaped and reshaped, it ended up with a structure. We should know this structure to be able to put our buildings on top of it. We should know something about the geological time scale. It is a little bit related to geologists, but we are going to take minor information about it. And then lastly, we are going to discuss unconformity. Unconformity, it means that it was something like one of these structures before, but it did not continue like this. It was weathered a little bit, then new layers came on top, so it is not in the real sequence of time. Soil or rock layers, but not in the real sequence of time. So these 4 points are very important for us to study. Number 1, geomorphic process, forces shaping the earth. We said that geomorphic processes are divided into 2 types of forces: endogenic forces and exogenic forces. Endogenic are internal processes. They originate from the inside of the earth. Exogenic, they are external processes originating from the earth's atmosphere, going to the earth's surface. So we should study both as the geomorphic process that shapes the earth. The first type, which is the internal geological process, we said that it is also subdivided into fast process and slow process. Fast process like earthquakes and volcanoes. Slow process like isostatic equilibrium and plate tectonic. Plate tectonic is the horizontal, mainly the horizontal movement of the plates. Isostatic equilibrium, you can consider it the vertical motion of the plates up and down. This takes very long time. It's slow process. For fast process, we have earthquakes and volcanoes. We said before that we should know that internal processes are constructive. So it means that it constructs the layers of the earth. But what it includes in the fast process, it includes earthquakes. Some of us would say earthquakes are destructive, volcanoes are destructive. They destroy the buildings, they destroy the structures, but they are destructive in terms of buildings and structures, but they are constructive in terms of the Earth. So this is the first type. The second type is the endogenic forces. Exogenic forces. The exogenic forces are the internal forces coming from outside. So when these forces come from outside, they destroy really what is really on the surface of the Earth. So these are forces originating from the Earth's atmosphere, and they come to the Earth to weather or to destroy these layers or structures. Examples of these are weathering, mass wasting, and erosion. Of course, we studied a chapter for this. Let's study one by one. Weathering. Weathering, it is, of course, it is the breakdown or the disintegration of the rock, but in place. The rock is standing in place, and something coming from outside, like air, water, or whatever, these forces coming to this rock disintegrates or destroys the rock formation. They are divided into mechanical weathering and chemical weathering. Mechanical weathering, when physical forces break rock into smaller pieces without changing the rock mineral composition. So it is one big piece of rock being destroyed into smaller pieces. That's all. Chemical weathering, it's a reaction. Reaction happening, destroying the structure of the rock. So this is the difference between mechanical and chemical weathering. Mechanical weathering is subdivided also into four things, 4 parts: frost wedging, thermal expansion, unloading and exfoliation, biological activities. Chemical weathering, it is something like what you see in the photos, where the main structure of the material itself is destroyed, similar to what you have seen here. How to prevent weathering? This is very, very important. Let's read, and I will tell you what I want to say. Geology defined the problem. Now we have a problem. Geotechnical engineering can provide solution for this problem. But do we need to prevent weathering? This is very important. Do I need to prevent weathering of rock for the sake of geotechnical engineering or not? When do we interfere in a problem? If the problem is extremely big, when we should not interfere, when we should say, as a geotechnical engineer or as an engineer in general, we are not going to interfere. We are going to let it pass and try to avoid it. How to do this? If the problem is extremely big beyond the limit of human beings, if you are having a destructive earthquake with an intensity of 8, you cannot design a building to carry an earthquake or to withstand an earthquake with a magnitude of 8. We can study 6.5, something like this, but 8, it's destructive. So if I know that in this place I have earthquakes and I'm expecting an earthquake of 8, then I'm going to let everyone living in this place go away, because I cannot design anything to stand in front of these forces. The other thing that would prevent me from interfering is that there is no need to interfere. Why to interfere? So let's take weathering as an example. Weathering is a very long process. It takes much longer than the lifespan of a structure. Therefore, we live with it. If I tell you that this rock will take 2,000 years to weather, my structure will decay, will be vanished within 100 years. So why should I prevent weathering? I don't need to prevent weathering. I should live with it. I will know only that within the lifespan of my structure, the time of my structure, I may have a limited amount of weathering for the rock formation. That's all. I will take it into consideration in my design, but I will not design anything to prevent weathering. So this is very important. Mass wasting. We said in mass wasting that we gathered mass wasting into 5 categories. Either something falls, or something slide, or something topple or slump, or something flow or creep, or something spread. What is this something? This something may be land, rock, mud, anything. So if I say landslide, so it belongs to this category. If I say mud flow, it depends to this category. If I say rock topples, it depends. It belongs to these categories, and so on. So these are the 5 categories that I study in case of mass wasting. How to prevent mass wasting? Again, geology defines the problem. Geotechnical engineer can provide solution. Solution may include. So now we are presenting solution. Why we are presenting solution? Because mass wasting is a fast process. It will happen during the lifespan of my structure. So I need to prevent this mass wasting, or to try to prevent. How to try to prevent? Reshaping of steep slopes. If I have a steep slope, I should reshape it to make it less steep. Using retaining walls with drains. If I use retaining walls, it will prevent big particles from falling on top of my structure. Using wire mesh shotcrete and rock bolts. These are to fix the big boulders to prevent them from falling. Using cultivated slopes. Of course, if you refer to the lecture for mass wasting, you will find photos and everything showing what is this. The third type is called erosion. Erosion is the physical removal and or transportation of material or weathered rock by mobile agents such as wind, water, or ice. So erosion is subdivided into 3 categories: wind erosion or abrasion, glacial erosion, and water erosion. What is the difference between erosion and abrasion? Of course, you can refer to the lecture, but it differentiates between, is the wind alone eroding the material, or the wind is carrying sand or fine particles that abrades the material. So both are more or less the same in effect, but one is due to the sole effect of wind, and the other is because of what the wind carry while blowing. How to prevent erosion? Do I need to prevent erosion? Yes, I need to prevent erosion. But not all types of erosion I need to prevent. Only water erosion is fast. If you have a flood, it would take anything in seconds. You can find buildings vanishing from your view in seconds because of a flood. But wind erosion or whatever else, it takes very long time. So only water erosion is fast and may affect our structure. How to prevent this, or how to help in protecting this? I have to, this is a levee. A levee is something like a big walk path inside the sea. Of course, the sea can can erode it in very long or very short time, depending on the tides and the flow of the water. So if I put here something to prevent the erosion, to help to stabilize the soil here, to destroy the big effect of the waves, then this would be very helpful for preventing something like this. So seashore and levee protection are needed for some places, and this is the size or the shape of these pieces. If you compare, this is the size of one of it, and this is the size of a human being. So it is very big. Second thing is the geological structure of the earth. We said before, number one, it was the geomorphic process shaping the earth. Then number two is the geological structure. What is the end of this shaping of the earth? What are the structure that we reached? The structure that we reached are two types. They are either primary or non-tectonic structures, or secondary, which are called also tectonic structures. So primary, these are formed during or shortly after the deposition of sedimentary rock or the consolidation of igneous rocks. They help to determine the original orientation of strata, old and young beds. It means that this is the original formation of the earth. This is how the rock layers were formed at the early beginning. The secondary tectonic, they were primary structures, but what happened is because of the earthquakes and volcanoes and the movement, the new structures were formed. These are we can see this in folds, fractures. So the rock starts to be changed in shape because of this tectonic movement. The third thing, we studied the geomorphic process, we studied the geologic structures of the earth. Then the third type, just an info something that is related to geology, but we take it, we need it a little bit in our study. We need to know, of course, layers of the earth were formed millions of years ago. The older layers are below, and as we go with time, we have different times, periods of time, different periods of time follow this till we reached our final time that we are living now. So in each type, of course, the fossils and whatever we find inside, it depends on what was there on the earth at this time. So this column represents the geological time scale. It is divided into 4 types of periods of time. One of them is called aeon, the second is called era, third period, the fourth is epoch. We can see this in this table. This is the aeon, era, period, epoch, and so on, and this is the duration of time. So aeon is a very big period. It is subdivided into here. This aeon is divided into 3 era. This era is divided into 2 periods. And it is subdivided into another 2. These are all divided into smaller epochs and so on. this is the amount of years it is given in million years. So it's a lot of time, but just for info to know what are geologists speaking about. But this is important for us. Why? Because it will help us to understand number 4. Number 4 is called unconformity. Unconformity means, you remember that we said that these are the layers of Earth. They were formed at the early beginning. They are more or less horizontal layers. Then because of tectonic motion and tectonic forces, they were a little bit disordered. We find faults and so on. Then at certain period of time, erosion will happen. Erosion will take this dotted line. Everything above this dotted line will disappear because of erosion. So at a period of time, part of the layers disappeared. If we go back to this this formation, this is the normal formation. But if I have some kind of erosion, maybe I will find that all of these layers are not there. Why? Because they were eroded with time. And maybe the last layer would be here at the bottom. Why it is at the bottom? Because all the layers in between were eroded. So this is what will happen here. These layers were eroded and new layers were deposited on top of it. So this line is completely different than any other line separating layers, because it is separating two periods of time. This is a very old period and it may be subjected to folds and faults and everything. Then erosion happens and newly layers were sedimented on top. So these new layers may be fully horizontal and not affected by any earthquake, because it was not there when earthquakes happened. So this line is called the unconformity line. Now we go into chapter, the third part of our lecture, which is called the geologic study using photo summary. We can put an end for this part and study this part in the next part of our video.